Angles of elevation and depression. Suppose a person on the ground sees a hang glider at a 38-degree angle above the horizontal line. This angle is then referred to as an angle of elevation. And so today we're going to talk about two different types of angles for word problems involving right triangle trig: angles of elevation and angles of depression. When thinking of an angle of elevation, most typically I want you to envision a triangle like this, or a right triangle like this, where we have a horizontal base here, which is going to be referenced as your horizontal distance in the word problem. Then you have where your right angle meets it. This is generally going to be your height. And then the diagonal here, or the hypotenuse, is going to be representative of any string or diagonal line of sight. Or they'll just reference it as the hypotenuse. All right? And then in the bottom corner here, this is where your angle is going to go. So your angle of elevation triangles, 99% of the time, are going to be drawn like this for the word problems, where you have a horizontal line that represents either the flat ground or your sight line horizontally straight ahead, and then your angle of elevation comes out above that. So then it falls into this corner here. The other angle we have to talk about today is that if at the same time a person is in a hang glider and see the person on the ground at a 38-degree angle below the horizontal line, then we're calling this an angle of depression. And so similarly, we'd have a triangle that would look almost like the flip of the one we have before, where our horizontal distance still represents the direct, straightforward sight lines, and then your vertical part that makes your right angle is still your height, and then this would be your diagonal or your direct line of sight, diagonal line of sight, any way you want to reference it. Or in this case, maybe there's a string attached here. And then your angle of depression is going to go in this top corner. And so this is how you would want to draw an angle of depression problem. So what you need to be aware of is for an angle of elevation, it all starts with the horizontal line here. And the reason they call it elevation is because the angle then comes up above that original horizontal line. For depression, you have your horizontal line, and then your angle starts below it, or depresses down below that horizontal line. All right, so now let's put some of this information to use as we try to solve some word problems. Suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So we're using the picture here. We've got our angle of elevation. We've got our 53 feet distance here. This is the height, but it's only the height from your eye level to the top of the turbine. You're missing this bottom piece here. Well, this bottom piece they give you in the problem itself as the 5.5. So at the end of this problem, we're going to have to account for that 5.5. But let's go ahead and start this problem normally. So if we're using trig, I know that the side opposite the 56.5 is the x, so this is my opposite side. And then directly beside it, the 53 becomes my adjacent. Opposite and adjacent is tangent. So we've got the tangent of 56.5 over 1 equals opposite over adjacent. Well, with any good trig problem, we're going to go ahead and cross multiply in this case. To solve the proportion, we get x equals 53 times the tangent of 56.5. And then we can put this in our calculator. In this case, we get x to equal 80.07 feet. But that's not our final answer. We still have to account for the 5.5 feet above the ground for the person's eye level. So at this point, we want to go ahead and add that in. because we want the total height of the turbine, which in this case makes it closer to 85.57 feet tall. You sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is about 6 feet above the ground, and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? Also, what is the diagonal distance to the rock climber? So in this case, we're going to solve two questions. Let's go ahead first and find the approximate height of the climber from the ground. Well, as I was reading through this, I noticed a key piece of information here: angle of elevation. So I'm going to go ahead and just draw my standard angle of elevation triangle, which is going to be something like this. Right angle here. This would be, put our rock climber up here, put our person down here. You got 6 feet here for your eye level, but we want to find the height, but we also want to find the diagonal distance in the second half of the problem. We currently know that you're 1,000 feet from the hill, so let's go ahead and try to solve this. Well, we know that the angle of elevation is 32 degrees, so we'll put that there. In this case, we know that the side that's marked X is our opposite side. The 1,000 is the adjacent. So let's just work with the two we have so far. Opposite and adjacent is tangent. So we've got the tangent of 32 over 1 equals X over 1,000. Well, here we want to cross multiply. So we've got X equals, oh, I forgot a 0 here. X equals 1,000 times the tangent of 32. In this case, we're going to get X to equal 624.9 feet. But we know that we're looking for the total height here. So we have to add in the 6 feet for the eye level. And we get we get the total height in this case to equal 630.9 feet. The second half of the question asked us to find diagonal distance, which in this case would be solving for y, which in this case would be our hypotenuse. In this case, we could use trig, or we could use the Pythagorean theorem now that we know that the opposite side length is 624.9. I'm going to use trig again. Let's say I use the adjacent and hypotenuse. Well, I know that's cosine, so the cosine of 32 over 1 equals y, or actually backwards, equals 1,000 over y. Cross multiply, you've got y cosine of 32 equals 1,000. I'll divide by the cosine of 32. And I'm going to get y equals, in this case, y equals right around 1,179.2 feet. Next problem. To approach runway 17 on the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent. Descent is essentially your angle of depression, starting from the height of 2,714 feet above sea level. The airport is at 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airport at the start of its approach? Here they want us to change our units of measurements from feet to miles. We're not actually going to worry about that right now. We're just going to go ahead and find it in terms of feet. All right, so as we look at this picture, we've got our triangle being constructed for us, the plane's eyes, or line of sight. We got it going down, creates our right angle here. Oops. What we don't know is the height of the plane. But what they do tell us is that actually the height of the plane is at 2,714 feet, but the airport itself sits 1,007 feet above sea level. So what we need to do with those two measurements is subtract them to find the actual length of the height of the triangle there. And when you subtract the two, you should get that measurement is 1,707 feet. In this problem, they want to know how far from the runway is the airplane at the start of its approach. So they're looking for the horizontal distance. So we're going to solve this using trig again. Well, here we've got opposite and adjacent. So it's tangent again. They're not always tangent, but in this case they just happen to be tangent more often than not. So the tangent of 3 over 1 equals 1707 over x. We're going to cross multiply. We get x times the tangent of 3 equals 1707. We'll divide by the tangent of 3 on both sides. And we should get that the plane is currently about 32,571.5 feet from the airport at the beginning of its approach, which is actually right around 6.2 miles, I believe. An airplane pilot sights a life raft at a 36 or a 26 degree angle of depression. The airplane's altitude is 3 kilometers. All right, so we've got an angle of depression of 26 degrees. The altitude or the height of the plane is 3 kilometers. What is the plane's horizontal distance, d, from the raft? Well, we'll start with our basic angle of depression triangle. So there's our triangle. We've got a life raft. We've got an airplane. And we know that the plane is sitting at 3 kilometers in the air. And the angle of depression is 26 degrees. And we're looking for the horizontal distance. So once again, we're going to use trig. So we've got opposite and adjacent, which is tangent. This is the tangent of 26 over 1 equals 3 over x. Well, we'll cross multiply, so that's x times the tangent of 26 equals 3. Then we divide both sides by the tangent of 26. And you should get x to equal right around 6.15 kilometers. So the plane currently sits about 6.15 kilometers from the raft at a horizontal distance. All right, first problem in the wrap-up. A rescue worker is located 175 feet above the ground in a lighthouse. He spots a ship on the water at an angle of depression of 62 degrees. How far from the base of the lighthouse is the ship? Well, we're going to start with our standard angle of depression angle. All right, and so now we can fill in some details. Right angle. We know that we're looking at a boat. Nice little boat. We've also got a lighthouse. And we know that the lighthouse is 175 feet in the air. And the angle of depression is 62 degrees. And they want to know how far from the base of the lighthouse is the ship. So they're actually talking about this distance here, but this distance is the same as this distance up here. So we can kind of superimpose it at the top of our triangle that represents our horizontal distance. All right, and so from our angle of depression, we've got opposite side here, and we also have adjacent side. Opposite and adjacent is tangent. So we're looking at the tangent of 62 over 1 equals 175 over x. At this point, we want to cross multiply. So that's x times the tangent of 62. Equals 175. So x times the tangent of 62 equals 175. Then to remove the tangent of 62, we'll divide both sides by it. And at this point, we want to take 175 divided by the tangent of 62, which gives us a distance of right around 93.05 feet. So this means that the boat is about 93 feet from the base of the lighthouse. Kyle stands 120 feet from the base of a tree. The angle of elevation from the eye level to the top of the tree is 40 degrees. What is the height of the tree to the nearest foot? Kyle's eye level is 5 feet. So let's just worry about solving that first problem. So we want to find the height of the tree using an angle of elevation. So we've got triangle, standard angle of elevation triangle there. Go ahead and draw a tree here. Cool. We'll put Kyle over here. Kyle's eye level is, what did they say? 5 feet. Put X there, and we know that Kyle is currently standing 120 feet from the base of the tree, and that the angle of elevation is 40 degrees. So at this point, we've got opposite and adjacent. And so to find the height of the tree, we're going to go ahead and use tangent again. So tangent of 40 over 1 equals x over 120. Cross multiply, we've got x equals 120 times the tangent of 40. So in this case, x should equal 101 feet. But we still have to add in Kyle's eye level, which in this case is 5 feet. So the tree has a total height of 106 feet.